Alright, hello everyone. So today let us solve an integral which I found from my textbook here. So the given integral is the integral of a square root x minus 2 divided by the square root of x minus 1 dx. And now for this integral, there are many ways to approach it. There are many ways to find the antiderivative or finding the substitution. The way that I'll be approaching this integral is that by multiplying by form of 1, which is the square root of x minus 2. So let me show you what I mean here. So we integrate the square root of x minus 2 divided by the square root of x minus 1. So we multiplying it with the square root of x minus 2 divided by the square root of x minus 2 dx. And now I can just simplify the denominator. I will have the x minus 2 divided by the square root of x minus 1 times with x minus 2. Okay, so what we are going to do is first I would like to expand my denominator inside of the square root. Then I'll be performing the completing the square. So here we will obtain the value, which is x squared minus 3x plus 2 dx. And now I'll be performing the complete the square approach, which is x squared minus 3x plus 2. I will obtain x minus 3 over 2 square minus 1 over 4. So in other words, this integral, this function, this algebraic function, I could express it as x minus 2 divided by the square root of x minus 3 over 2 square minus 1 over 4 dx. Now what we are going to do? Well, there are many ways if you want to continue on with the next step, but I'll be using the trig substitution. So I'll be substituting x minus 3 over 2 with 1 over 2 secant of theta. So let me write down here. So x minus 3 over 2 is equal to 1 over 2 secant theta. And when we take the first derivative, it will be 1 over 2 secant theta times with tangent theta, d theta, sorry. Now, what we are going to do is I'm just going to simplify the denominator. So I could simplify as 1 over 2 square root. We know that the second square theta minus 1 of the identities for trigonometry is equal to tangent square theta. And then the numerator, well, x can be expressed as 1 over 2 secant theta plus 3 over 2. And I can simplify it further. 3 over 2 minus 2 would be, if I'm not mistaken, negative 1 over 2. And I'll be multiplying it with 1 over 2 secant theta tangent theta d theta. So it's not that pretty to look at, but we could simplify it further. But before that, well, we could simplify it for this constants here, and therefore the square root of tangent square theta, it will be the absolute value of it. Oh yeah, we could like factor 1 over 2 from the numerator. We left with secant theta minus 1 divided by the absolute value of tangent theta times with secant theta times with tangent theta d theta. Now, to get rid of the absolute value, we have to restrict the domain for theta itself. And we know that tangent theta will be larger than 0 if the value of theta is between 0 inclusive up until pi over 2. You can't include pi over 2. If you include pi over 2, then, well, it's not defined on the graph itself. So now by getting rid of the absolute value, you are left with secant squared theta minus secant theta d theta. Now from here, we know that the integral of secant squared theta is tangent theta. So you will have tangent theta over 2. And for secant theta, will be ln the absolute value of secant theta plus tangent theta. So like this. And don't forget your constant c. And how are we going to move on from here? Now, first things first, we have to draw a right angle triangle so that we can leave our final answer in terms of x. So we know that secant theta is equal to 2x minus 3. Therefore, the right angle triangle, if I can draw it, will be theta. So it will be our adjacent will be 1, our hypotenuse will be 2x minus 3. Then our the opposite of the angle will be, if I'm not mistaken, 2, and then the rest will be x minus 1, x minus 2. Alright, if I'm not mistaken, that will be it. Now, we know that tangent theta, by using Saussure, tangent theta will be the opposite divided by the adjacent. And we know that 2 divided by 2 is 1, therefore we are left with the square root of x minus 1 times with x minus 2. I'm going to write down here, so 1 over 2. Now we know that secant theta is 2x minus 3. We know that tangent theta is the square root of x minus 1 times with x minus 2 plus. So it's a very nice solution. That's a very nice question. It really tested me. But I have to be honest that I was reading it out since my final answer is this form, but the scheme answer is a bit different. So at that time I wasn't sure of myself, but by rechecking countless of times I realized that maybe I should check it on the website. For an integral calculator is just available on Google. Therefore my answer is similar to Google. So yeah, I think there's another approach to solve this, but my approach is just basically using a trig substitution. Who knows, maybe there's a better way to approach. Well, I hope that this really helps you, and if there's any questions, please do let me know, and I'll see you later.